This is a vectors question taken from AS Maths Paper 1 in 2018, so the pure paper from that year. Question 3, worth 4 marks in total, so shouldn't be too difficult. Given that the point A has position vector 4 minus 5 and the point B has position vector minus 5 minus 2, A, find the vector A to B for 2 marks, and in part B, find the magnitude of that vector for a further 2 marks and give your answer as a simplified surd. So we note that we're given position vectors, so they point from the origin. So I can actually do a little sketch of this to help me find my find the answers to the given questions. So let's do x and y axis, and this is 4 minus 5, so the coordinates 4 minus 5 is where A is, so 4 minus 5 about here. And B has position vector minus 5 minus 2, so from the origin it goes back 5 and down 2, so maybe about here, so this is B. Okay, so the vector that points from A to B is the one that starts at A and goes to B. So, and it's directed, so it's going in that direction. So what we can do is we can look at the differences in the x and y coordinates. You could also do, if you wanted to find the vector A to B, then you could do B minus A. But I'm actually just going to inspect. So to go from A to B, I go minus 9 in the x direction, and in the y direction I go up by 3. And I can write that as minus 9i plus 3j if I wanted to. I'm just going to come over here and check to see if I get the same thing. B is minus 5 minus 2. And I'm writing it in the column vector format as opposed to the ij formats given. B minus A is 5 minus 2, take away 4 minus 5. So minus 5 minus 4 is minus 9. And minus 2, take away a minus 5, which is a plus 5, goes to 3. So I've checked that, and that's all good. So in part B, we have to find the magnitude of this vector. So I'm quite glad that I drew it like this in the first part, because I can see this is just a straightforward application of Pythagoras. So the magnitude of the vector points from A to B is, so this length was 9 and this length was 3, so I just need to apply my Pythagoras, square in the sides, add them together and then square rooting. So I've got the square root of 81 plus 9, which is the square root of 90, and I can simplify this surd as is asked. So the highest square factor of 90 is 9, so you can list some square factors to help you if you wanted to. I can see 9 is the highest, so I write this as 9 times 10, and I can separate the surds when it's multiplication on the inside or division, not when it's addition or subtraction. And the reason I do that is because square root of 9 becomes a 3, positive 3 because we're talking about lengths, and it's being multiplied by root 10, which doesn't simplify. And that's the question complete. To find out more about vectors or simplifying surds, go to studyworld.com.